This is 4-2. Law of cosines. This one is set up for the other two possibilities. Side angle side and side side side. So law of sines is more powerful, but law of cosines is actually much cleaner, much easier to work with. But it only solves those two cases, which is kind of sad. All right, so what we're going to do is go back to coordinate geometry, draw a nice little picture, put a nice little acute triangle on my coordinate system. Oh, I like that. I love when they squeak. We'll call the origin vertex A. We'll call this point here vertex B. It has a coordinate of something. We'll talk about that in a second. This is vertex C, and we're just going to give it the coordinates x, y. So in other words, I can take C and move it left and right, up and down, wherever I want it to go. If this is B, and I didn't tell you how far away from A it is, but it's opposite big C, then how far is it from A to B? What do we usually call that? When we're talking about just regular triangle, and I say, here's big C up here, what's the side called?
Little c.
The length of it is little c. So I'm going to call this coordinate c comma 0. Because whatever c is, little c is, it will be the length of that side. A, of course, is 0, 0. It's at the origin. So what I'm interested in is little a, to start off. How do I find the length of little a according to that picture?
I don't know.
So we've done it before with the sum formula.
I don't like that.
Distance between 2 points, how do you find it?
The distance formula.
The distance formula. So to find a, it's going to equal the square root of something squared plus something squared. What goes in the first one is the difference of the x's. What goes in the second one is the difference of the y's. So from C to B, the difference of the x's is x minus c. From C to B, the difference of the y's is just y minus 0, better known as y. All right, let's get rid of the square root. So square both sides, this becomes a squared is equal to, do I want to expand it out? Yeah, sadly. X minus c.
Wait. Why would I do that?
Oh well. X minus c all squared becomes x squared minus 2cx plus c squared plus y squared. So I square both sides of the equation to get rid of the radical, and I expand out the quadratic. Now we're not on a unit circle, so you can't say x squared plus y squared is equal to 1. Damn it. We're not on a unit circle. I'm sorry. Ah, sad.
Your dreams have been shattered.
I was going to say, isn't x squared plus y squared? Oh, let me read my notes.
Go ahead and take another nap.
Oh, I'm missing one part of the picture. Draw an altitude. How tall is that altitude?
X. Right?
X minus 0.
Well, draw a little picture here. How do you plot the point 2.5?
It's just y.
It's just y, right? It's the y coordinate that tells you how high it is. So this is y.
Yeah.
Yeah.
That's what I have to say.
What's the length of this side? from here to here? From here to here?
That's that is from 0 to x. So that's just x.
That's just x.
So yeah,
Worried.
I listen sometimes.
I'm worried. All right, so the next thing I want to set up is looking at just vertex A, what's the cosine of A equal to? Now remember, cosine only works on right triangles, so it only can work on the
It
blue
equals y.
over,
I don't know.
what do we call that side?
Wait, what?
Well, if this is vertex A and this is little a, and this is vertex B,
What?
if this over here is vertex A and opposite it is little a,
Well, with the right triangle, wouldn't it be y?
I know, but I'm just saying, labeling the green triangle, if this is vertex A and this side is little a, and this is vertex B, this is
Little b.
little b. All right, so finish that off. So cosine of A is equal to
Y over b.
y over b. Sine of the vertex A is equal to
Sorry, what?
sine of A of that right triangle is
X over b.
x over b. Wait a minute.
Are we doing the little triangle or the...
The one with a right angle. A's over here.
Yes.
So when you take sine of A, what's opposite?
Well, then why was it cosine? We put y on top then.
That's why I'm asking. You said y over b. I wrote y over b.
Well, you're the teacher. You should know if I'm wrong or not.
Cosine of A is equal to...
X over b?
I don't mind making mistakes as long as we catch them. Sine of A is equal to
Y over b?
y over b.
The world goes round.
The world goes round.
No, it doesn't. It's flat.
Solve for x, solve for y. So what's x equal?
X is equal to cosine of A times b.
Huh? Say it, well,
Times b.
b times cosine of A. It's best to put the b front so you don't think it's multiplying the a on the inside. It's kind of like, should you write 2 times the square root of 3 or the square root of 3 times 2?
Neither.
Which one's actually better?
It doesn't matter.
It does.
I know what you mean.
I know, but some people forget to write the dot, or they make that line a little bit
John.
too long, and it screws things up.
I know what you mean.
Convention, you put the 2 up front. So the same thing with cosine and sine, you try to put the number out front. So what's y equal to?
B
B
times sine of A.
Sine of A. You'll find this set up in a lot of things that we're going to do in this chapter, where the x-coordinate is something times cosine, and the y-coordinate is something times sine. It's a common setup. All right, so take these two, plug it in there.
Why?
Why not?
Why would you do this?
So that becomes a squared. Can't do anything with that. What's the x become?
B cosine of A.
And it has to go in parentheses, so b cosine of a, and it's all squared. Minus 2
C
parentheses cosine, oh,
B cosine of
b cosine of a
A plus C squared
plus c squared
plus B times sine of A squared.
b times sine of a all squared.
Oof. Why would you do this?
Because it's going to come out with, spit out a formula. Kind of like we did the sum of the cosine angles, or no, the difference of the cosine angles, and we did the triangle, and we rotated it, and did the distance formula, and it spit out the right formula. This is going to do the same thing.
That's it.
So this is a squared
You don't remember the sign.
is equal to
Mental abuse to humans.
That's
Told you.
mental abuse for humans. This becomes
that squared.
b squared
Cosine of A squared. I don't know.
cosine. Careful word. You don't put a squared.
Cosine squared A.
Cosine squared a minus 2. I'm going to put it in alphabetical order. BC times cosine of a. Because little c and is she sleeping again? I swear. And then plus c squared plus b squared sine squared a.
Oh, you said that the cosines were easier to work with.
It is. When we get to the formula, it'll be easy. All right. Anything look interesting?
Did all the
sine squared and the cosine squared?
The sine squared and the cosine squared. So if you look at just these two, what can I do with them?
They equal 1.
Well, kind of, except there's something in the way, the b squares. So what can I do with b squares?
Take them out.
So if I factor out b squared, what's left behind is cosine squared a plus sine squared a. But sine squared plus cosine squared is 1. So that whole thing, the underlined green stuff, just becomes
B squared.
b squared. So this becomes a squared is equal to b squared minus 2bc cosine of a plus c squared. And all we have to do is neaten it up, and that's the law of cosines. So let me neaten it up a little bit. A squared equals b squared plus c squared minus 2bc times cosine of a. Law of cosines.
2bc.
Now if I change a few of the letters around, so it looks a little bit more recognizable for you, in a second it will be. Instead of A, I'm going to replace it with C. So if I replace A with C, what do you think the other side becomes?
It's going to be
It's not going to be this, because you can't have C squared on both sides. It'll just cancel out. So if I change A into C, what does B change into?
Doesn't it stay B?
Well, look at this. This is A, B, C. So if I put C on the other side, what's that leave?
It's B will still be there.
B will still be there.
And then you'd be subtracting A squared.
No. I'm not solving it. I'm not moving it. All I'm doing is saying, if I go back to this picture and I replace A with C, and I replace C with A, what would happen to the formula?
Just the letters will switch.
Yeah, so the C would become
A.
A. So this becomes A squared plus B squared
So simple.
minus 2AB times cosine of
A. C.
C, because I switched the C and the
A.
A. This is the one that's written in most books. Let's do SAS.
You okay?
She's delusional.
She needs a nap.
I thought you said you weren't starting that job until Friday.
No, I'm going to do it tonight.
But why are you tired right now? Alright, so here's our triangle. Do the exact same thing as law of sines. You set up the picture. I'm going to show you how to recognize, if you don't recognize right away which formula to use, law of sines or law of cosines, I'm going to show you with this one and then not do it again. So angle C here is 40 degrees. That's up here. Oh, this marker is just dead.
Well, then don't use it.
Let's do this one.
You alright?
Oh, now she's singing.
I think she took some cough syrup.
And
Y'all
that's
haven't seen that video.
She's been drinking.
Jeez.
told you she was up partying.
40 degrees up here. Side A is 12 centimeters. That's over here. Side B is 20 centimeters. And try. Oops. Law of sines. I just want to set it up and show you that you can't do it because
You can't.
I'm just saying. Let's try it. So
You
which one do you want to try to solve for?
No.
Oh, and this is side C.
You would want to try to solve for either one.
Well, you see two sides, and right away you try to think of an angle. So what angle do you want to solve for? A or B?
Go B.
Go with B. So if we try to solve for angle B, we'd go sine of B over what?
20.
20 is equal to
Is the sine of 40.
sine of 40 over
C.
C.
But you can't.
And you can't because
Yeah.
you have two variables. So if you get stuck with two variables, use the other formula. In either case, if you set up law of cosines and you have two variables you don't know, go back to law of sines. Does that make sense? Anytime you can't solve it, just go to the other one.
Sure.
So we have angle C here, so the formula I'm going to set up is this. If if I had angle A, I'd put A first and it would be angle A. If I had angle B, I'd put B first and use angle B. So that's the only adjustment you have to do with law of cosines. All right, so do I know side C? Nope. So I put C squared. Do I know side A?
Yes.
Yeah, that's 12 squared.
This would be 144.
B is 20 squared. I highly suggest you don't write down what each and every little piece is, because you're going to just type it all into your calculator one fell swoop and hit equals. That way you don't have to do what's called rounding error.
Well, I mean, we already know what it is. Can't we just go ahead and put it?
Yeah,
Like-
but it's
like 12
let your
squared,
calculator
12
do the, well, I'm sorry, let my calculator do the work.
I would.
2 times 12 times 20 AB. Cosine of C in this case is 40 degrees. So if you just type this huge string into your calculator and just hit enter, it does all the work for you. But be careful, that's still C squared equals. It's not what C equals, it's what C squared equals. Which
I guess C squared is 176.3.
176.3. So C is equal to, well, the square root of 176.3, which is approximately
Oh, let me get that for you.
13.3.
Let me get that for you.
13.3, I think I said centimeters, yeah. All right, if we're going to solve this triangle, we really want to set up law of sines now. So here we found C, but now we can't use well, we could. We could use law of cosines to come up with the angle, but it's much easier to do law of sines. We just found side C, so now this one is equal to 13.3, and all of a sudden I can solve for angle B. There's something I forgot. Hold on.
What was that?
I have no
Just
idea what
measure
that
by
was.
word.
It's one thing I always forget.
What is
It's approximately 13.3.
You should always find the angle that is not obtuse.
Sorry, what?
You should always go for the, is it the biggest angle? I always forget. I didn't even put it in my notes. You should always find the largest angle possible. So if you had a choice between A and B, and you know the sides are 12, 20, and 13, out of A and B, which one's going to be bigger?
B.
B?
Because B is across from the largest side. So don't go looking for A, because then that gives you the possibility of two triangles, and you want to make sure it forces itself to be one triangle. So you go for the biggest angle, therefore if it turns out to be obtuse,
Could it be possible to be no triangles?
no, law of cosines always is guaranteed because it's SAS, it's a guaranteed proved triangle. All right, so you always go for the biggest angle, so you might want to put a note, find B.
Just say find the biggest angle first.
No, I'm being stupid. Not biggest angle. I know I said it, but I really want to reverse my order. If B is the biggest angle, it could be acute or it could be obtuse, and we don't want that possibility, so we choose it to be the smallest. So I want to find A. I'll write that in detail here. I always forget to say it. When solving for side, angle after law of cosines, always choose the smallest angle.
When solving for
The one opposite the smallest side. That way you don't have to go looking for the two possibilities, acute and obtuse. If you're looking for the smallest angle, it's guaranteed to be acute. All right. So that formula down there is useless. I'm not sure if it would work. We want sine of A over little a, which is 12, is equal to sine of 40 over 13.3. That's the one we want. Okay. So, what's measure of angle A equal to then?
Measure of angle A is going to be 35.5.
Multiply both sides by 12, divided by 13.3. Sine inverse of it, what was it again?
35.5.
35.5 feet.
Centimeters.
Isn't that the angle?
That's the angle. So therefore it would be measured in
Radius.
Bananas.
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 35.5 bananas.
Oh, I swear. So the measure of angle A is equal to 35.5 degrees. What's the last thing we can find on this triangle? If this is 35.5 degrees, how do I find angle B?
You
So
just
plant
add,
the
Add these two together, it's 75.5.
then subtract.
Subtract from 180, that leaves you with...
104.9.
Bruh, my calculator wasn't even on.
Isn't it
No answer.
104.5?
104.5?
Yes.
104.5. So if we went through and solved this setup over here, if we solved this setup over here, we would have found, what's 104.5 minus 180?
75.5.
Be quiet. We would have found that B was 75.5. But it wasn't the small angle that we were looking for, it was the bigger angle. So that's why you want to go for the smaller angle all the time. It's guaranteed to be the acute, and then the other one spits out whether it's acute or obtuse is determined. So now we have all three sides, all three angles.
So that's an obtuse angle.
Yeah, that's a definite obtuse angle.
Even though you drew it cute.
Yeah, the picture's irrelevant. You get used to it. The picture is really more for finding the location of the angles versus the sides. Other than that, it's not a very accurate picture. All right, how would we use it to solve
We would.
this one?
No, we would.
For example, ooh, the squeaky marker. Find measure of angle A, measure of angle C, and I think that's it.
Yay.
Given
They're right there.
A is equal to 7 centimeters, B is equal to 14 centimeters, and C is equal to 18 centimeters.
I put bananas.
Now, what setup is this?
35.5.
This is size.
Angle.
Side, side, side. So this is side, 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 a provable, guaranteed right triangle.
Is it really?
Oh, provable congruent triangle. I shouldn't say right triangle. It's not a right triangle.
So
How can you tell if this is not a right triangle?
Because you said it wasn't?
No.
Well, you could also.
How do you prove it?
A squared plus B squared.
A squared plus B squared equals C squared. So C would have to be the biggest one, so you'd have to go 18 squared. Is that the same thing as 7 squared plus 14 squared?
Nah.
No. So this is definitely not a right triangle. All right, so the angle we're looking for is A or C. Which one do you want to find?
I thought we had to find both.
We do, so pick one.
Yeah.
Go for A. So if I'm looking for A, the formula is going to start off with A squared equals B squared plus C squared. Don't worry that it doesn't look like Pythagorean. It all depends on the letters that you're given. Minus 2
BC
BC times
cosine of A.
A.
Was that right?
So it starts with an A, it'll end with an A. If it starts with a B, it'll end
So
with
whatever's
a B.
out front first would be what the cosine is.
Mhm.
Okay.
So if it's little a on the far left, it's big A on the far right. All right, plug in what you know. Well, A is 7, so that's 7 squared. B is 14, so that's 14 squared plus 18 squared minus 2 times 14 times 18 times cosine of?
E.
I have no idea.
A.
A? What are you, Canadian?
A.
A?
A.
Now, it's up to you how you solve for the cosine of A. but I give you a big suggestion of what to do. It makes life easier later on. My trick is this. You're trying to solve for this a way over here to the far right. In front of it is a minus sign. So what you can do is take this piece and shift it to the left. Take this piece and shift it to the right. When you do that, the negative turns into a positive, and the 7 thing turns into a. So it's basically you're just picking them up and
So you just want to switch both sides.
it makes life easier. So it becomes 2 times 14 times 18 times cosine of A is equal to 14 squared plus 18 squared minus 7 squared. It just makes solving for that A a lot simpler. What would you do first?
Find out what the right side is first.
Find out what the right side is and the beginning of the left. So what's 2 times 14 times 18?
I don't know.
Neither do I. Actually, if you want to let your calculator do all the work,
It's 504.
504, but you could just move the pieces around. What's 14 squared plus 18 squared minus 7 squared?
471.
171. So then you move it over and you get cosine of A is equal to 471 divided by 504. And then what?
You find out what that is.
How?
You put it here.
Yeah, how? So the measure of angle A is equal to, what function would I use?
Cosine inverse.
Cosine inverse of 471 over 504. By the way, you know you made a mistake if the numerator is bigger than the
Because it's a
denominator.
one, right?
Yeah, it's bigger than 1, and you cannot have no triangles in this situation. It's guaranteed. So this is approximately
20.8.
28 degrees. Oh, you know what I forgot to do? Oh, I didn't draw my picture. I'm usually very good at drawing my pictures. A, B, C. So A is 20.8 degrees now. Small a is 7. B is 14. C is 18. All right, so far I got that.
Yeah.
Oh, yeah, just that. Now what?
Well, now you can just use sine, can't you? Find C.
Law of sines?
Yeah.
Yep.
And then you use that.
But I highly suggest you, choose the biggest angle, which is C. All right, so law of sines, that becomes
It's sine of C.
sine of C, which we don't know, over
18.
18 is equal to
Sine of 20.
sine of 20.8.
Over 7.
8 degrees over 7. So C is going to be equal to sine inverse of 18 sine of 20.8 divided by 7.
It's 65.5 degrees.
So sine, measure of angle. Measure of angle. I like putting this in front of C especially because little c and big C look
Similar.
similar when you write them. So it's approximately what?
65.5.
65.5 degrees. So this is 65.5 degrees. I like the picture because it kind of reminds me of what I'm looking for. What's the last thing I need to find?
You don't have to. Just find A and C. That was it.
Fine. Can I find the last one?
No.
Yeah. How do I find angle B? That's the easy one. Yeah. So you just go 180, subtract the 2 angles you already have. What's the first one? Oh, there it is, 20.8. So this would be the measure of angle B.
93.7.
Well, it's really close to a right triangle. 93.7. I always like law of cosines. It's kind of simple.
I thought the bigger angle had to have the bigger side.
It better.
If angle B is bigger than angle C, then
Ooh, yeah, something's wrong. Did I label it right? The biggest angle should have the biggest side. The smallest angle should have the smallest side. So why are those backwards? Did we screw up a calculation? A is 7, B is 14, C is 18, minus 2 times 14 times 18 cosine of A. Am I going to need my calculator?
Here you go, catch.
Hold on.
Okay.
I have the answer here. I got the measure of angle B being 45 degrees. And we got the measure of angle B to be 93 degrees. Are you sure you did this calculation?
Yeah, I just did it
60,
again.
70, 85. Yeah, that works. I chose 20.8. Measure of angle A, 20.8. Yeah, that seems reasonable. Something's wrong. We chose. Oh. You know what we did wrong?
What'd you do wrong?
No, we didn't do that wrong. Hold on. Angle C is supposed to be the biggest angle. Why is it coming out really small? Hasn't it done that? It's definitely a mistake. I just don't know where it is. Sine inverse. Sine inverse. 18 sine 20 by C. 65. Well, I got 65.9 now.
That wouldn't make much of a difference though.
No, it won't. C is here, 18 is there, 20 is there.
So this possible we no triangle at all.
No. Something's just screwy someplace in our calculations and I don't know what it
Did we mess up on the angle A?
is. Yep. How do we mess up on angle A?
I don't know.
We broke the rule I wrote down over here and erased.
Okay, we're great.
When you're looking for an angle, always look for,
This biggest one first.
in this case, it's law of sines, you want to go for the smallest one. Law of cosines, you want to go for the biggest one.
You know what?
Dang it.
Now
Dang
you gotta,
it.
Now you gotta cut all of this out of your video.
Dang, no, I'm going to leave it in.
Uh,
Because these are the mistakes people make with law of cosines, including yours truly, me. So if you're looking at this picture, what is the biggest angle?
C.
C.
Well, technically B.
But this is what happens when you choose the wrong angle. You get this strange setup and things don't make any sense over here. So we really should be looking for C in the formula. So you can't just be random with angles. So C squared equals A squared plus B squared minus 2AB cosine of big C.
Oh, God. I know, right?
I like leaving mistakes because mistakes are important. They're what actually teaches you. Doing it right all the time doesn't teach you anything. Because
Okay.
you're doing it right all the time.
So in cosines, you choose
Biggest
the
angle.
biggest angle.
Did I say sine for the smallest? Yeah. After you use law of cosines, law of sines, you go for the smallest angle.
Okay.
Just in case you
Right
didn't
there.
choose the right one with law of cosines. But if you pick right with law of cosines, you don't have to worry about law of sines. So pick the largest possible angle, C. So this is 18 squared is equal to 7 squared plus 14 squared minus 2 times 7 times 14 times cosine of C. Phew. I'm going to break it down simply. Cosine of C is equal to, parentheses, 7 squared plus 14 squared minus 18 squared divided by 2 times 7 times 14.
You have a calculator.
Oh, that's right. So, measure of angle C is going to be approximately the cosine inverse of this ugly mess up here. Just make sure you put a parentheses in the beginning and a parentheses at the end. You'll be fine. Oh, you have to put a parentheses here and here, and then just type it in your calculator. You could do it slower like we did last time and come up with the right answer here rather than the wrong answer over there.
Okay, I got that to be 113.8.
And that makes a lot more sense. If this is 113.8 degrees, what does that make angle B? Well, then it's a 20.8 plus 113.8, subtract from 180,
45.4.
and if that's 45 point, what is it? 4?
That makes more sense too.
Then the biggest angle is C, and the biggest side is 18 is directly opposite. The smallest angle is A, and 7 is the smallest side opposite. The middle angle is 45.4, and the middle side is 14, which is opposite. That makes sense. Where the information we got first didn't make any sense at all. So, when you're using law of cosines finding an angle, always go for the biggest angle. When using law of sines after the law of cosines, looking for an angle, go for the smallest one. That should keep things rather safe. That's probably the only confusing thing about law of cosines.
He's trying to figure out
Which angle? So biggest for cosine, smallest for law of sines.